Hey guys, today we're going to be talking about Pascal's triangle and the binomial theorem as it applies to algebra 2. I don't even know why it's in this class, but I hope we can learn it well here. So first of all, before we get started, we're going to need a quick recap or first teaching of combinatorics. So if you already know what a factorial is and stuff, you can skip ahead. But we're going to start with the very basics this time. So have you ever seen this notation before with a factorial after a number? That means you multiply that number and then you multiply by that minus 1 all the way until you multiply by 1. So for example, you can compute 6 factorial equals 6 times 5 times 4 times 3 times 2 times 1. And if you do that with a calculator or in your head, you get 720. So why do we even define such a mathematical notation here? Well, you can it's actually used to count how many ways you can arrange some stuff. So let's say in this case you want to arrange 6 things in order. So how many ways can you order 6 things? Well, there's how many choices do you have for the first spot? Well, there's 6 things that you could put first. That's all of them. For the second spot, you already picked one thing, so you only have 5 remaining things to choose from to fit in the second slot. And then you have 4 things for the third slot, 3 things for the fourth slot, and so on until you only have one slot left for putting your final item. So that's what a factorial is about. It's like if you're listening to Taylor Swift's new album, The Life of a Showgirl, which has 12 tracks on it, and you want to figure out how many uh, ways you can listen to it on shuffle, then there's 12 factorial ways. 12 ways to pick the first song, 11 ways to have a second song, and then 10 ways to have a third song, etc. times all the way down to times 1 way for the final song. So you know what a factorial is. I would like to introduce a new notation that involves factorials. So this is what you probably should have seen in your notes before, and this is just counting how many ways to choose a, a certain number of items from a larger set. So, for example, let's say you want to add 4 songs from The Life of a Showgirl to a playlist. So how many ways can you choose those first songs? 4 songs. Well, you might think it's just 12 ways to choose the first song, 11 ways to choose the second song, 10 ways to choose the third song, and 9 ways to choose the fourth song. However, if the order does not matter, then you have to divide by the number of ways of arranging the 4 songs because any arrangement is equally valid. So we divide by the number of arrangements of 4 songs in order. So that would be 4 times 3 times 2 times 1. Or that's just 4 factorial on the denominator. Another way you can think about this is there's 12 factorial ways to pick 12 songs, right? In order. So 12 factorial is counting order. Now you also divide by the number of orderings of the 4 songs you do pick to be on your new playlist. But for the other 8 songs that you don't choose to be on your playlist, that order does not matter either. So you also divide by 8 factorial. So basically, either of these formulas is okay to use when you're trying to calculate such a number. This formula is usually what you do in practice, that this you could also do on a calculator. Again, you want to calculate the number of total ways to do something, or pick 12 songs in order with respect to order, because that's easier to calculate. And then you divide, because there are some parts that don't matter. It doesn't matter what order the 4 songs that you chose are in, and it does not matter what order the 8 songs that you did not choose are in, but it does matter that the 4 songs are not part of the 8 that you didn't choose. So hopefully that makes sense. Let's look at another quick example. Let's say 7 choose 3. So you can use the above form, this formula for 7 times 6 times 5. You put 3 numbers on the top, and then 3 times 2 times 1. That's 35. Hopefully I did that right. 7 times 5. Yeah, that's right. Or you could use that formula, 7 factorial over 3 factorial, and then remember the 8 here is from 12 minus 4. So you also do 7 minus 3 factorial here, which is just 4 factorial. So you have 5040 divided by 6, 3 factorial 6, 7 minus 3 is 4, 4 factorial is 24. You can do that on the calculator, that also equals 35. So I've explained what exactly a combinatorics number is. So let's see how they are. So Pascal's triangle is just a neat way to organize all of these combinatorics numbers. By the way, this notation, this is pronounced n choose k, 12 choose 4, 7 choose 3. So here's the very familiar Pascal's triangle that you've seen before, and so on. So, however, the more reasonable explanation would be you start with combinatorics numbers. So each row is, you change the top number, the number of items in the big set, and then throughout the row, the number on the bottom increases. You can confirm all of yourself that the first 3 rows that I've written out here actually matches. So now would be a good time to go over some basic theorems about these kinds of numbers. So first of all, anything choose 0 equals 1. By definition, that just means you have so many ways of choosing 0 things or doing nothing, and there is by definition only one way to do nothing. Now, you also might have noticed on the notes that it said that the Pascal's triangle can be reversed and it's reflected and still the same thing, and that is written out here in more mathematical forms. The way to think about this is that the number of ways to choose k items from a set of n is the exact same thing as not choosing the remaining n minus k items here. So, and if we go back here, choosing 4 songs from the life of a showgirl to be on your new playlist is the same thing as choosing 8 songs from the life of a showgirl to not be on your playlist. So that is combinatorics numbers. Now, and another thing I briefly want to mention, although it might be obvious, is that if the n is smaller than k, then that combinatorics number is 0. So for example, 6 choose 7 equals 0 because there's no way you can choose 7 items if you only have 6. So now let's go on to the binomial theorem. This is the big thing. theorem. Okay, so it states that if you expand x plus y all to the nth power, you get n choose 0 x to the n plus n choose 1 x to the n minus 1 times y plus n choose 2 times x to the n minus 2 y squared, and so on until you get to n choose n and then x to the 0 y to the n. Now let's look at a quick example to see why that's the case. So let's say we have something of x plus y cubed equals, if we write it out, x plus y times x plus y times x plus y. So you notice to get x cubed, you have to pick 3 x's. X times x times x. And that's the only way you can get 3 x's. That's also the same thing as choosing none of the y's. So that equals, if you choose none of the y's, that's the first term. And I'll just replace the 3's with 0, the n's with 3's to show it more properly. Now, if you want this term, x to the n minus 1 times y, you have to choose exactly one y, or exactly n minus 1, or 2 x's in this case. So you could do x times y, you could do x times y times x, you could do y times x, and there are 3 choose one ways of picking one y out of 3 parentheses. And the pattern continues. There are 3 choose 2 ways of choosing 2 y's or 3 minus 2 x's. And finally, there's 3 choose 3 ways of choosing 3 y's, or choosing 3 minus 3 x's. So if you compute the binomial numbers, you get 1x cubed plus 3x squared y plus 3xy squared plus 1y cubed. Okay, let's do a quick example here. So let's say you have x minus 2y, let's say, to the 5th power. So our theorem here uses x plus y, so let's change that up a little bit. X plus negative 2y to the 5th power. Now we write out our theorem. If n choose 0 ways of picking 0, negative 2 y's, or picking the remaining 5 x's, we have n, or n is 5 here. So, and then 5 choose 1 ways of picking 1 of the negative 2 y's, or picking 5 minus 1, or 4 of the remaining x's. And then so on. 5 choose 2, x cubed negative 2y to the 2nd, plus 5 choose 3, x squared negative 2y cubed, plus 5 choose 4, x to the 1st times negative 2y to the 4th, plus 5 choose 5, and then 0x to the 0, which is just 1, and negative 2y to the 5th. Now, our theorem, we're actually mostly done here. All we need to do is calculation. So if you need practice on doing calculations, we can do it right here. It's 5 choose 0 is by definition 1. 5 choose 1 is 5. In fact, n choose 1, any number choose 1 itself, because you always have n ways of choosing exactly one item, because there are n items, of course. X to the 4th, and then 5 times negative 2 here is negative 10. 5 choose 2 is 10. And negative 2 all squared is positive 4. So 10 times 4 is actually positive 40. x cubed y squared. Now 5 choose 3 is also 10. You can compute that. And negative 2 cubed is negative 8. So let's write a negative here. 10 times 8 is 80. And 5 choose 4 is 5. Negative 2 to the fourth is positive 16. So 5 times 16 is 80. 5 choose 5 is also, by definition, 1. So the only way to choose everything. And negative 2 to the fifth is negative 32. Okay, so that's a long calculation, but if you know these, if you can use this explicit formula here to calculate the Pascal's triangle numbers, you don't actually have to recursively compute every single row down to the fifth row. By the way, that's the 0th row, that's the first row, that's the second row, and so on. You don't have to compute all the way to the fifth row to get these numbers. You can explicitly calculate them. Now, for a final bonus part, I'm going to show you why this construction of recursively writing down Pascal's triangle actually works. Notice how for any number, the two numbers above it actually sum to that number. I'm going to show you this by walking you through a real life example. So we're going to go back here, back to 12 choose 4 example. We're picking 4 songs from the life of a showgirl to put on your album. And as we've computed before, there's 12 choose 4 ways of doing that, right? Okay, so let's say you really, really like the song Eldest Daughter. You relate to it. It sounds cool, all of that, right? So you are guaranteed to put that in your playlist. Now there's 11 more songs to choose from, and there's 3 more spots left. So 11 choose 3. This is the number of playlists that have to include Eldest Daughter. Now, let's say you really hate the song Eldest Daughter. It's not relatable. That track 5 just doesn't hit like the other ones. So now you definitely still don't include that song, but you are actually, you still have all 4 spots remaining. And so this is, you definitely include the song Eldest Daughter. This is counting the number of playlists of 4 that do not include that song. And since these events are all encompassing and mutually exclusive, they add up to the total number of playlists of 4 songs from the entire album. And if you compute the numbers with a calculator, you'll find that it actually works. So this was a very, very, very long video, but I hope you understood combinatorics numbers and the binomial theorem a lot better. And just remember to take into account the negative signs. This is the easiest way not to mess up. So, alright, I hope you stayed long enough to watch the whole video, and I'll see you guys next time.